So note it down. Note it down. The valency is actually the number of electron gain, lose, or share by an atom. The number of electron gain, lose, or share by an atom. Share by an atom to attain the stable electronic configuration to the nearest noble gas. To attain the stable electronic configuration to the nearest noble gas. Okay. So if I talk about that, what is valency? Valency is this means the number of electron gain, lose, or share by an atom. So like first, for example, first of all, I'm just going to write the electronic configuration of the nearest noble gas or the noble gas only. Helium, neon, argon, krypton we have. Helium we have 2. Neon electronic configuration is 2, 8. Argon is 2, 8, 8. And krypton is not in our syllabus. So I'm just deleting this one. Okay. So for example, if I'm having an element like I'm having nitrogen, I'm having oxygen, I'm having fluorine, I am having aluminium, I'm having sulfur, phosphorus, okay, and hydrogen. So electronic configuration of hydrogen, that of hydrogen is just 1. That of nitrogen is 2, 5. That of oxygen is 2, 6. That of fluorine is 2, 7. That of aluminum is 283. And that of sulfur is 286. And that of phosphorus is 285. So can you tell me that the nearest noble gas of of hydrogen is? Hydrogen nearest noble
Nitrogen.
hydrogen. No, hydrogen's nearest noble gas. It is helium that is going to have the 2 electrons. The first shells it need to fill. Okay, helium is an noble gas, neon is a noble gas, and argon is a noble gas. Okay, so the nearest noble gas. So how many electron does hydrogen need to complete to have the electronic configurations of helium?
One more.
One more. So it will be considered as, we'll consider it as, okay, this is going to have one more. So we have +1. Okay, so its valency will be, hydrogen is valency will be 1. Now, can you tell me that what nitrogen is going to do to have the what is the nearest noble gas of that of nitrogen? Is it helium
Neon.
or neon? Neon. Yes, nearest noble gas is neon. So can you tell me the nearest that what nitrogen is going to do?
Add 3 more.
Add 3 more. Okay. So we have to add 3 more here. Okay. Got it? So we will say that nitrogen valency, if we are adding electron, because electrons are negatively charged, so we are adding, so it will acquire a negative charge. So this will say that its valency is -3. Got it? Then that of oxygen. Tell me that of oxygen.
Neon.
Neon. Then what it will going to do?
Add 2.
Add 2 more. Okay, so it is 2. It is fluorine here. So what it is going to do?
Add 1 more.
Add 1. So it will be -1. Is it adding -2? It will be going to have O because it is adding. So it will be -2. Okay, now this one, aluminium 283 electronic configuration. That of aluminium is 283 and that of sulfur is 286 and that of phosphorus is 285. So what aluminium is going to do? The nearest noble gas of aluminium is
Argon.
not argon. It need to have 5 electron. If it need to have the electronic configuration of argon, then it needs +5. And if it want to have this one, then it will just donate 3. Donate 3. So what it will going to do? Donate 3. So the number of electron gain, lose. So it will lose 3. Got it? So if it is losing, its valency
Okay.
is +3. Got it? And
Yes, sir.
that of sulfur?
Uh, to lose
So they will no sulfur electron nearest noble gas.
argon.
Argon. So this will be +2 or -2. So it will require 2. So it will require 2 electrons. So it will be adding 2. So it will be having -2 charge. Okay. Adding it is -2,
Okay, sir.
losing it +3. Okay. Then this is 5 here. What it will do?
+3.
It will
So
add.
minus.
So minus. Okay. Got it. Now you
Mm.
understood, Rima and Alvina, that what is valency?
Yes, sir.
Okay. So we have just a questions here from NCRT. Let have some questions from the NCRT. Just give me a. Now in the previous class, we have done the what is this? What is this? Do we have discussed isobar, isotopes, and everything?
No, sir.
No,
Not discussed. I think we
no.
have discussed.
No, sir.
Okay, just a minute. Yes, we have not discussed this one. Na? So electronic configuration we have discussed in the previous class. I am sure. So let's do this one. Just a minute. Do this one, please. On the basis of the information that you have studied, please do this question. Done? If the atomic number is this one and number of neutron is this one, what is the atomic mass?
19.
19, because atomic number is number of proton. Now, atomic number is exactly equal to number of proton. So number of proton plus number of neutron is equals to atomic mass. So it will be 19. Got it? Got it?
Yes, sir.
Next, number of proton in this one?
9.
9. Very good. Number of electrons? Number of protons are equals to number of electrons. Yes, 9. And the atomic number of atomic, name the atomic species. So what is the name of this species? Which is atomic number is 9? Whose element is going to have atomic number 9? Which element is
Fluorine.
going?
Sir, fluorine.
Yes, it will be fluorine. Fluorine. And what is its symbol? Symbol FL or FE or F only?
Fl.
Only F. Do the next one.
Sir, number of neutrons is 26.
What are you saying, Rima? Beta?
Number of
76.
neutrons is 26.
Not 26. Atomic mass and atomic number. You know that number of atomic mass, actually atomic mass is actually equals to number of proton, number of proton slash number of electron slash number of, sorry, atomic number of electron slash or atomic number, any three it can be. Okay, if it is not carrying charge, number of proton, number of electron, and atomic number, plus means it can, we can choose anyone, plus number of neutron. So here atomic mass is given to you. Okay, then tell me. Okay, now tell me, Prima, if it is 32, mass number is 32 and atomic number is 16, then number of neutron will be?
Sir, number of neutrons will be 16.
Number of neutron will be 16. Yes. Then here number of proton will be
16.
16. Number of electron will be 16. Now do this one, please.
Atomic number 12.
Atomic number 12. Yes, atomic number is 12. Okay, then
12.
this one is 12. Then
12.
this one be 12. Okay. And this will be, what is the name of this one?
Magnesium.
Magnesium. Yes, Mg magnesium. Do this one.
Sir, 1. Sir, it's 1.
Okay. What is saying?
I'm saying it's 1.
1. Okay. Then this one?
It's also 1.
It is also 1. Okay. Then
It's 1.
then
It's 1.
mass number is 2.
Sir,
Then it is
number
also
of
1.
neutrons will be 2, right? How 1?
Mass number is 2, na? Atomic number is 1. Because
No,
number of one.
number of neutrons I'm saying.
Yeah, it will be 1 because proton plus atomic number is 1. So it must be neutron there. 1. That's why it is having 2. Because it is saying 1 proton and mass number is 2. So it means there must be 1 neutron there. That's why it is 1. Okay, and atomic number is equals to this one. Got it? Got it?
Okay, sir.
That's hydrogen.
Okay. Next, just a minute. Here is question. Rutherford alpha accelerating experiment was responsible for the discovery of just a minute, just a minute, just a minute. Okay. Do this one, please. Done this one? Tell me fast. The composition of nuclei of two atom species is X and Y are given under this one. Proton and neutron are there. So what is the composition? Tell me. The composition of the nuclei of two atomic species X and Y. The protons and neutron in X is 6 and 6. So what is it? Tell me. It is carbon 12, mass with 12 and atomic numbers 12. And this is carbon, atomic number of proton is representing atomic number. And this one, when you add it, you will get to 14 here. Okay. Got it?
Yes, sir.
No,
Got
sir,
it?
I didn't got it.
What I'm saying here is that when you add these two, proton and neutron, you will get the atomic mass. So mass is represented here. And that's why I'm writing C here, because carbon has atomic number 6. Number of proton represent the atomic number. So carbon is atomic number 6. Here is also Y is also going to have, and these two together are known as isotopes. Okay, so note it down. Let's study isotopes. What are isotopes? So isotopes are the elements having the same atomic number. Okay, isotopes are the elements. Isotopes are the elements having same atomic number, but different atomic mass, atomic masses. Okay, but different atomic masses. So first we have isotopes. We're talking about isotopes like we have carbon, carbon 12 and carbon 14. Carbon 14. They both are going to have the same atomic number. Here is same atomic number, but these have two different masses. So atoms of same element having same atomic number but different atomic masses are called isotopes. You understood? Similarly, hydrogen has three isotopes. Hydrogen has 1, 1, 1, 1, 2, and 1, and 1 and 3. In this case, here you see that atomic number is exactly equals to atomic mass. But you know that atomic mass is the sum of neutron plus proton. Atomic number is the sum of atomic mass. Sorry, atomic mass is actually the sum of number of neutron plus number of proton. And here is mass is 1. And here the neutron is also as new proton is also 1. So what we are going to add here? Tell me. What we are going to add here? It will be 1 or 0. Because if you add 1 here, then it will become 2. So it will be 0. So in this case of isotopes, which is protium is an isotopes of hydrogen which is going to have 0 neutron. It is the only atom in the whole of the elements. Okay, only the element which has 0 proton, 0 neutron, sorry, 0 neutron. No neutron is present here in the hydrogen. In this case, it is an isotope which has 1 neutron and 1 proton. 1 neutron and 1 proton. And here, tell me the number of neutron and proton in this one. Tell me the number of neutron and proton in this elements. Tell me. Number of neutron and proton.
1.
1. 1 what? Number of neutron, proton, tell me. 1 what? 1 is proton or neutron or? Hmm?
Number of protons.
Yes, it is number of proton is 1 because atomic number is represented by this one, and number of neutron is 2. So because that's why 2 plus 1 is 3. That is atomic mass. Okay. That is atomic.
Okay, sir.
Got it? Got it. So when we have hydrogen 1 and 1, it is 0 neutron. Okay, we have neutron and we have proton. So it has 1 proton and 0 neutron. When we have 2, 1, we have 1 neutron and 1 proton. And when we have 1 and 3, so whatever the number is written here, it is actually equal to proton. And the difference of this and is equals to the difference of the top and the lower one is always equals to number of neutron. Got it? Got it? Please do this one.
Yes.
Do this. Copy this one. Done this one?
Done, sir.
Okay, just a minute. Do this question in your notebook, please. Just a minute. Here we have this question. So we have the formula for the symbol of H, D, and T. Tabulate their subatomic particles and found in this one. What is H, D, and T? H is the hydrogen first isotope. That is, this is D is actually deuterium. This is 2 and 1. And 3 is the tritium. That is 1 and 3. And these are all the isotopes of hydrogen. These are isotopes of hydrogen. So what is H, what is D, and what is T? And they are talking about the subatomic particles. So we are talking about electron, proton, and neutron. So we are just making electron, proton, and neutron here. And we are just having elements here. Okay, just making on the next page. So again, we have here, this one is H, hydrogen 1 and 1. This is hydrogen 1 and 2. This is hydrogen 1 and 3. It's named it tritium, sorry, tritium, or only H. It is deuterium and this is tritium. Okay. Now it is electron, proton, and neutron. So tell me how many electrons are present in this one? This I have written wrong. This one should be 2, this one should be 3, this one 1, this one 2. Okay, tell me fast. How many electrons are present?
2,
Hmm? How many
2,
electrons are
and
present? Tell
One.
me. Hmm?
One.
1. This one?
Two.
Electron.
Wait.
All of them are going to have the same atomic number. Electron and proton are same. 1, 1, 1 in all.
Okay.
Proton?
One.
1,
One.
I'm also going to write here H positive 1. Now tell me how many electrons are there in H positive 1? H positive 1.
0.
0. And I'm writing here H minus also. And how many are there?
2.
Yes, it will be 2 because it is already 1 and 1 has been borrowed, so it is 2. Now this one, proton. Proton.
1,
Hmm?
1.
1, then 1, then 1, then 1, then 1. Proton will be same in all because all of them are going to have the same atomic number. Okay. Now tell me the next. Number of neutron. Number of neutron. In this one,
0.
0. In this one, tell me
1,
1.
2.
1. Subtract this one and this one.
Okay.
This one,
2,
2. This one,
0,
0. This one, 0. Do this one, please. Copy this one, please. Done?
Yes, sir.
Next. Now we shall be studying one important thing here is that we shall be studying the percentage of some elements. Actually, this is percentage of iso, the atomic number. For example, percentage of atomic mass. Yeah, mass percentage, mass percentage, or we can say that average atomic mass, average atomic mass. For example, you know that chlorine exists in two isotopes. Chlorine exists in two isotopes. One is 17, which is 37 with mass. Another is going to have chlorine 17, which with 35 mass. Okay, now you know that this chlorine is going to have 37 mass. This chlorine is going to have uh, 35 mass. This is present in 25% in nature, and this is present in 75% in nature. So what should be the average atomic mass of this one? So the formula for this one, because we just calculate the average atomic mass. So average atomic mass has a formula that is equals to average atomic mass is the formula that is equals to mass of the first isotopes into its percentage. Okay. Or let's if the percentage is not given. For example, this is said this is 25% given to you. So if it is given that this is 25%, then it is understandable that other will be the 75% because 100 minus 25 will get 75. So if it is something is 60%, then the other thing will be 40%. If something is 10%, then the other will be 90%. The same thing happens here. That if I'm saying that 25% of this one, so we'll write here, X is a percentage of 1 upon 100 percentage of first one into 100. Okay. Into the average atomic mass, into mass of isotope first or A1 plus x or we can say y percentage means other percentage upon 100 into mass of A2 other isotopes, other element. Okay. So what does this means representing? That this means that if we have x, so x% of this one is given, that is 25%, and this was 75%. So right here 25% upon 100 into 37 plus, okay, plus here write it, that is 35, sorry, 75% is other and upon 100 into what is the mass of other one? That is 35. Try to solve, and what you get the answer, please tell me. Please let me know. Try to solve it.
I didn't understand, sir.
Hmm?
I didn't understand.
You didn't understand that they are the two isotopes of elements, chlorine, and they exist in two different forms. One is 37 with mass 37, other is of 35. So we'll take the average mass. Average mass. So average mass is equals to the percentage that if it is existing 25% in nature, other is existing 75% in nature, this one is existing 75%. So there is a formula that x into x percent of the first one upon 100 into the mass of the first one, which is we are at. It is 25%, this is 25 upon 100 into the mass of this one into the percentage of other one is 75 upon 100. For removing the percentage and we divide it by 100, okay? And then the mass of this element is 35. What you are going to do, you cut it, you will get 1 by 4. And what you do, you will get 1 by 3 here. Sorry, 1 by 4 here. And you will get 3 by 4 here. Okay? 1 by 4 and 3 by 4. So what you are going to do here is, this you one multiply, you will get 37 by 4 plus, when you multiply this one, 35 into 3, you will get 105 upon 4. You add all these, you will get 4 here. And when you add it, you will get 7 and 5, 12, 1 carry. Okay? And this 13. So this will, sorry, 14, 42, 142 by 4. Got it? So when you divide it, when you divide 142 by 4, what you are going to get it? Tell me. What you are going to get it? So when you divide it, you will get 72. Sorry, 71. 71 divided by 2. When you divide it, you will get 35.5. So that's why we have the chlorine mass in decimals, because it is in average. Okay. Got it? So do it properly. Let me give you the solution for this one properly. So you have to do this like this. Okay. Just a minute. So note it down like this way. Chlorine occurs in nature in two isotopic form. One is 35U and 37U in ratio 3:1. So ratio, if it is given ratio, then it means if you want to get the ratio, so ratio of 35 is 3 times. So 3 upon 1 into what you are going to, the ratio is 3:1. So if you write it into the fraction, then we have 3. If you do the 4 part, 1, 2, 3, 4, then 3 part is for 32, 35U. 3 part is for 35U and 1 part is for 37U. So this is 37 and this one is 35U. So what we are going to have a ratio here is, what we are going to have the ratio. The ratio will be, if we have 4 part total, out of 4 part, 3 part is the fraction for this one. Okay, so we can say that something is in 3:1 ratio. So it means that 75% is this one and 25% is this one. Okay, please do it. Are you doing? Copied? Tell me fast.
Just a
Do it fast.
done.
Okay, just I'm going to ask you a simple question. If something is divided in 2 is to 2 ratio is to 1, okay, A and B ratio is 2 is to 1. So what is the percentage of A and B? What is the percentage of A and B? What is the percentage of A and B? Tell me, Nabila.
90.
Hmm? So what does it mean? That if we have total 3 parts, 1, 2, 3, the 2 parts is of A and 1 part is of B. So we can say that if I made this fraction, so out of 2 part is of A, and out of 3 part, 1 part of is of B. So if we multiplied by 100 and this we multiplied by 100, you will get the ratio. So when you divide it, you will get 66.66% for this one. And when you divide it, you will get 33% for this one. Got it? So let me give you one more time. If I'm having ratio that A and B has ratio 4 is to 4 is to 4 is to, or we can say that they have the ratio 2 is to 5. 2 is to 3, right? Its ratio has 2 is to 3. 2 is to 3. So what is the percentage of A and B? If the ratio is 2 is to 3, then what is the percentage of A and B? Tell me fast. Tell me. What is the percentage of Alvina? Are you there in the class?
Uh,
Yes, sir.
Why are you not responding today?
uh,
Yes, tell me.
A is 40%,
And B is?
60%.
And B is 60%. So what you are going to do is you add this 2, you will get 5, and then 5 by 2 into 100. And then 5 by 3 into, first you add this, that will become the denominator. Okay, and then the ratio of this one into 100. So you will get 5 divided by 100, you will get 20. 20 into 2, you will get 40%. And here you will get 20. 20 into 3, you will get 60%. Got it? Got
Yes,
it?
sir.
Please copy this one. Done? Done?
Yes, sir.
Yes. Yes, sir.
Okay, now do the next. Just we are just going to have another questions. Calculate the percentage of this one. Calculate the average atomic mass of bromine. Calculate the average atomic mass of bromine. Percentage is given to you.
Sir, I didn't get the answer.
You didn't get the answer, so let me help you. Average atomic mass, atomic mass will be equals to, here, this is given to you, that is 79. Okay, the percentage of this one, first one, upon 100 into the mass of the first one, that is 79, plus the 50.3 upon 100 into the mass of the other one, that is 81. Now tell me. Tell me fast. Do it fast. It will be very simple. What you are going to do? This is approximately equal, okay? Just you need to multiply these two terms, and whatever the answer comes, you have to add the two decimals. But it will be very difficult for you, okay? So the other thing that you can do here is that, because they both are going to have the same, on an average, they are going to have the same atomic masses. Sorry, 50%, it is nearer to 50%. This is also nearer to 50%. So its average atomic mass would be 80.003. And let me explain you that how it is. That is 49.7 into 79. You have to multiply it actually, okay? Whatever the answer comes, you have to put the after 2 decimal place. Okay, got it? Got it?
Sir, I got
So
796.06.
what you get when you multiply this one, you will get 79. What you are going to get here
No, not for that.
for all?
Like I got total. Yeah,
79, 79.
6.06.
No, actually, it will be nearer to 80.03. 80 point something.
Oh,
So let me help you that when you do it, I'm just doing it by calculator, but you have to do it by your own because this, when you actually multiply it by this one, so you will get for 490.7 multiplied by 79. You will actually get, when you solve it like this way, okay, when you add it, you will get 3926.3, and you have to put, when you divide this number by 100 also, this you will get 3926.3.